Okay, what are we given here? We have f equal to this function, and we are supposed to find the derivative of f using only the definition of the derivative. And they clarify in the question we can't use any of the quick rules to find this derivative. We have to use the definition of the derivative. So let's write that down. That's the limit as h approaches 0 of f of x plus h minus f of x all over h. Now, to deal with this problem, I'm struggling with this cubed root there. I would like to cube that to get rid of the cubed root. Now, the usual strategy is to use the difference of cubes. Let's write that down. We would want a cubed minus b cubed to be factored, so we get a minus b multiplied by a squared plus ab plus b squared. So in order to cube my function, what I'd like to do is set a equal to f of x plus h and b equal to f of x. So in order to make sure that this formula is complete and we're using it correctly, we'll have to multiply top and bottom by all of this, a squared plus ab plus b squared. And how about, to be notationally convenient, we'll call all of that c, where we let a and b equal what we've shown on the page. So if we let all that be c, we just have to multiply top and bottom by c. And this is going to clean up our limit. So on our next step, what we have, and we take our limit as h approaches 0, the whole top, all of this top, is all of this, which is equal to a cubed minus b cubed. So how about we just write that on the top part? So we have our numerator is a cubed minus b cubed. And on the bottom, we just have hc. Okay, now what happens when we take a cubed and b cubed? Well, if we look at how we defined a and b, we can think about what happens when we cube that. So f of x plus h, well, we'd be plugging x plus h into x, and there's this cube that we'd be dealing with, the cube root, and if we're cubing that, all of it just goes away. So on the numerator, we can write that we have x plus h cubed plus 1 minus all of x cubed plus 1. And we still have hc on the bottom. Okay, so our limit now becomes, if we expand out the whole top, we have x cubed plus 3x squared h plus 3xh squared plus h cubed. That's expanding out the h plus x cubed. And then we have a plus 1. And then in our other term, we have minus x cubed minus 1. And the bottom is h and c, h multiplied by c. Now, whenever you have your limit by definition written out in this form, so that you have a polynomial on the top with x's and h's, and you have your h on the bottom, and your whole goal in this process is to try to cross out this h on the bottom. That's what's causing you the problem of you having 0 over 0 and having an indeterminate form that you can't figure out your limit. You have to do some algebraic maneuvers to figure out the limit. But once you have it written out like this, it should be the case that this h crosses out. We might have to do some canceling out first, but if we look closely, the x cubed cancels out, the plus 1 and minus 1 cancels out, and now every term that's left, all of these terms that are left have an h in them. And that should happen every time you're trying to simplify these limits. So if we cross out our h on the bottom, there's an h in each term on the top that goes away. And now we're at a point where we can literally just plug in our limit. As h goes to 0, we can replace h with 0 on our very next step. So we get no more limit now, and just 3x squared on the top. And then on the bottom, we have c still to deal with. Let's retract. What is c? So going back up to the top, we said c is a squared plus ab plus b squared. Okay, but what is a and b? Well, we put a and b right over here. So when we plug in h equal to 0, actually this is just f of x, and b is just f of x. So c is f of x squared, f of x multiplied by f of x plus f of x squared. Let's write that down. So on the denominator down here, we get f of x squared plus f of x multiplied by f of x, that's just f of x squared again for that ab middle term there, and the b squared, that's also f of x squared. So the whole thing breaks down into, we have 3x squared on the top, and we have 3 copies of f of x squared on the bottom. So actually those 3's will kindly disappear for us. 3 on the top and the bottom goes away, so we don't have to write that. And we just have f of x squared on the bottom. And let's write that out. What is that, f of x squared? Well, it's x cubed plus 1, and then to the 1/3 power, but it's being squared, so 2 over 3. And that gives us our final answer.